In the name of God, in the name of who without doubt is capable and voice, welcome to your own channel. I hope all of you be healthy and fine. Welcome the first episode of Learning SAP program. Actually, in this episode, we are going to introduce the SAP program, and also we will analyze and design a simply supported beam in this episode. The first thing before I start the introducing of the SAP program, there is a lot of students that have confusion with the SAP program and Etabs program, that they don't know that which program they should use. For example, suppose you have a structure element like beam or truss, and you want to design it, and if you design in Etabs, it will take a lot of your time, because in Etabs we don't have any specific template for a specific structure element. You have to draw in Etabs every structure elements, every part of a structure elements, whether it's a point, member, angle, separately, and it will take a lot of your time, because Etabs program is actually programmed for integrating of the structure building. It means if you have a building or a different type of the structure, it is good that you design in Etabs. But if you have structural elements like stair, like truss, beam, frame, so it is the best option that you select the SAP program. What does it mean SAP? S means structure, A means analyze, and P means program. It means structure analysis program. In SAP, actually, we have for every structure elements a specific template. For example, you want to design and analyze the truss. So just select the template of the truss, give your data, and then you can access on your truss. So it means that every type of structure elements that you have, you should select the SAP program. And if you have any type of structure buildings, you can select the Etabs. So there is no problem that when you want to design a building in SAP, there is no problem, you can do it, but it will take a lot of your time. And also there is no problem that you design a structure elements in Etabs, but it will take a lot of your time. So actually, all of you know that we have different versions in every software. Okay, but in the structure softwares like SAP, like Etabs, like SAFE, if you use the latest version, it is much better that you use the old versions, because in a new or latest version, there is a lot of visibility, there is a lot of accessibility, there is a lot of opportunity than the old versions. So keep and try to install in your computer the latest version of the structure softwares. So it's actually the SAP program. Okay, in here, like other we can say like other programs, we have the menu bar, file, edit, view, define, draw, and in here actually we have the toolbars that every necessary task in here is. For example, drawing, analyzing, we can say design of the steel structure, design of the concrete structure, deform sheet. It means every important task is available in this toolbar. And this portion is actually called drawing bar, and this window is actually called drawing window. Another thing, in here if you see, actually we have the units. Okay, the first unit is actually a unit for determining or unit for integrating of the load. The second unit is actually for length of the member, and the third unit is actually because of the temperature. Actually we don't need too much for temperature, just we need in the software the unit of the length and unit of the load. So the first row is actually belongs to load, and the second one is actually belongs to length of your member. So actually what is important, or what are the important steps in the SAP program? We have some steps, okay, in SAP program, and if we keep these steps, we can successfully design and analyze our structure. The first one, every type of structure that we have, the first one, we have the step of modelization. It means you have to complete the drawing of your model. The first step in SAP is actually modelization. It means you have to complete all related theory or all related data that is related in your model. The second step in our Etabs is actually when you actually determine your model, that it's my model, whether it's a beam, whether it's rust, then the second one, you have to define your model. Define your model, what does it mean? It means that you have to select the sections, materials for your model, which type of the load acting on your model. Okay, what type of section is your model? Is a angle section, is a actually channel section, box section, plate section, rod section, what type of section? Then you have to define the material for your model, that it's a actually made from concrete, is actually made from the steel, is actually made from the rebar, which grade. So you have to define it. Then you have to define type of loads, which type of load is actually acted on your model, on your structure. You have to set it. And the third step is actually assign. Then you have to assign the section. Once you create the section, the second one, you assign the section. Now this member is angle section, that member is a channel section, that member is a box section. Okay, you have to set it. And another step, the fourth step, is analyze. Then you when you complete the step of modelization, define the model, assign, then you have to analyze your model, and the last step, you have to design the model. So what we do in analyze model and what we do in design model. Actually, in analyze model, we need to find the capacity or ultimate strength of our structure, or ultimate strength of our structural elements. So, for example, we have type of the dead load that acting on the our model is 15 kN. And when we actually analyze it, we see that, oh, this member is failed due to 15 kN. So what should we do? We have to improve the strength of that member. Improve your section, improve your grade, or other ways. And in a design portion, we have to find the best cross section for our, we can say, for our member. So in an analyze portion, we have to find the capacity or strength or ultimate strength of our member. But in a design, we have to determine the best cross section for our member. So now, let's start for designing of our simply supported beam.